Hi, welcome to my channel. In the previous videos, we discussed about the linear SVM classification, linear support vector machine classification, and also we discussed about the soft margin classification, and also nonlinear support vector machine classification, and polynomial 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 kernel. In this video, we are going to find out the similarity features, adding the similarity features. So that means here the support vector machine is can perform the classification on the linear separable data, and as well as the non-linear separable data. So in the linear separable data, we are applying the concept called as a linear SVM classification and a soft margin classification. Now for the non-linear classification, we are applying the concept of non-linear SVM classification, and also we are using some kernel tricks like polynomial kernel, like that. So in this video, we discussed about we are going to adding some similarity features. Based on the similarity features, we are going to classify the non-linear separable data. So what is the meaning of linear separable data? The data is going to be separate with the help of a simple linear equation. For example, here the data set will look like here the form of a positive class and a negative class, like this one. And here we are going to draw a line with the help of this line with the simple line equation. Okay, we are going to separate the data into two parts. Simply this type of technique is called as a linear separable data. Okay, whereas coming to non-linear classification, okay, non-linear model. So the data set may be in the form of a like this one. Okay, it contains a half-moon data set. This is not separable with the linear equation. At that time, we are going to use the non-linear fashion to separate the given data into two parts. Simply it is called as a non-linear fashion. Okay, so here for example, here in this example, okay, these are the data set. It contains positive points and negative points. So here we are unable to classify these 2 points with linear equation. So we are going to apply the concept called as a non-linear fashion. Okay, non-linear fashion that separate the with the help of non-linear equation. We are going to separate the data into two parts. Simply that is called as a non-linear classification. So here we are going to apply a concept called as a we are going to add a new features for the based on the existing features. Then we are going to separate the data into linear equation. Simply that is called as a adding a similar features. Okay. Now here we are going to see the concept called as a similarity features. So here the technique is called as a we are having the non-linear problem. Okay, non-linear problems are there. For example, here in this data set, we are having the blue points are there, blue points and green points are there. So that means triangles and squares are there. So these are two points are there. These two set of points are there, like blue points and green color points. So these are unable to classify with the help of linear equation. Okay. So at that time we are going to create a new data set with the help of existing data set. Simply that is called with the help of we are creating a new features. So that is called a we are going to add a tackling the non-linear problems. So that we are going to add a features computing the similarity function. That means we are going to create a new feature based on the existing features with the help of similarity function. Okay, which measures the how much each instance resembles a particular landmark. So simple process is called a similarity features. For example, here we are having the one dimensional data set. It contains only one feature. So here the class labels are like here blue colors and green colors are there. Okay, these I want to separate these blue color points and green color points with linear equation is not possible. So at that time we are going to create a new features with the help of some landmarks. landmarks. Landmarks are very, very important. With the help of landmark, we are going to create the data into different features. Okay. Now, so for example here, we are going to add two landmarks like x1 equal to minus 2, x1 equal to, so here x1 is on x-axis we are having only one feature. For the x1, we are selecting two features as a landmarks. One landmark is at x1 equal to minus 2, and one more landmark is at x1 equal to 1. So there are the two landmarks we are going to identify. One, this is the one land first. This is the one landmark. Okay, this is x1 equal to minus 2 and x1 equal to 1, and these are the two landmarks we are identified. Based on these two landmarks, we are going to convert the data into other format of data, and that other format of data we are going to apply the linear equation. Okay. Now here we are going to see the similarity function with the help of Gaussian radial basis function with gamma equal to 0.3. Okay. Now the Gaussian radial basis function, that is pi of gamma into gamma of x comma l equal to exponential minus gamma into mod of x minus alpha l whole square. This gives the radial function. It identifies the similarity features. Okay, here x is nothing but your new point with the help of, and L is nothing but your landmarks. So here L are nothing but two landmarks are there. One is x equal to landmark x1 equal to minus 2, and the x1 other landmark equal to 1. We are the base of these landmarks, and we are going to find out the different distance between the other features, other variables. So, okay, we are finding out the distance between the similarity between this landmark with respect to minus 4, with respect to minus 3, with respect to minus 2, with respect to minus 1, with respect to 0, with respect to 1, with respect to 2 and 3 and 4, like that. And also we are going to find out the similarity between the other landmark between the that is with respect to x landmark, other landmark equal to 1. That is we are going to find out the similarity between the minus 4 to and x equal to 1, and minus 3 to 1, and minus 2 to corresponding landmark, and okay, like that we are going to find out the similarities with the help of Gaussian radial basis function. Okay, this is a very, very important formula. Now this is a bell-shaped function varying from the 0 to 1. If the value is 0, that means if suppose this is the landmark 1. Okay, that landmark 1 equal to minus 2. If you compare the similarity between the minus 2 to minus 4, that is very close to the 0. That means it is very far away from the minus 2. Like that, if the value is close to 1, okay, that means that is a very similarity there. Okay, so like that we are going to find out the similarity function. Now here we are going to see the how we are going to find out the similarity function with respect to x equal to minus 2 to and x equal to minus 1. So here we are having the two landmarks are there. So the first landmark equal to x1 equal to minus 2, and the other landmark equal to x1 equal to 1. Now we are going to find out the with respect to our original data set. Okay, the original data set points are minus 4, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. So we are going to draw all the values in the on the x1, that is equal to your original values. Now for that we are going to give the labels as a 1, 1. So those things are called as a blue color points. Those color points are called as a blue color point, and the green color points are represented to 0, 0, 0, like that. Okay, so like that we are placing the labels. Now we are going to check the distance between the similarity between the original point with respect to the x2. That is we are creating a new feature with respect to the landmark 1. What is landmark 1? That is equal to minus 2, and this is the landmark 2 equal to that 1 value, x equal to 1 value. So with these two values, we are going to find out the similarity between the original value and the corresponding landmark equal to minus 2 and landmark equal to 1 here. So now the formula for it to find the similarity function is gamma of pi into gamma of pi of x comma l equal to exponential of minus gamma into mod of x minus l whole square. That okay, where gamma equal to 0.3. Now we'll see the how we are going to calculate this function. Okay, now with respect to x equal to minus 2, with respect to x equal to minus 2, okay, that is landmark 2, and the first value equal to the x value equal to, here the x equal to minus 4, and the landmark equal to minus 2. Okay, now we are applying the concept of pi of 0.3 with respect to what the x value, x is nothing but minus 4, and the L equal to the landmark equal to minus 2, that is equal to exponential power of minus gamma nothing but 0.2 minus 0.3 into the distance, what the x value now, x is nothing but minus 4 minus of the what the landmark value minus 2 whole square. Okay, so that gives you exponential minus 0.3 into minus of minus, that is gives the 2 square. Okay, that is equal to 4. That is means exponential of minus of 0.3 into 4. That gives the value of corresponding exponential value. So that is equivalent to 0.3. So like that, we are going to find out the similarity between the minus that is second landmark with respect to minus 4, and that value equal to 0. Like that, we are going to find out the similarity between the first landmark with the other element, that is 3 minus 3, that is equal to 0.74, and we are going to find out the similarity between the second landmark with minus 3, that is equal to 0.01. Like that, we are finding the similarity between the each and every landmark with corresponding with respect to each and every element in our data set, linear data set, okay, non-linear data set. Simply this process is going on. Now we are finding that these two values are there. So these are the new features. So that is x2 is one feature and x3 is a other new feature. So based on these two new features, we are going to draw the graph. So based on this distribution of the x2 and x3, we are going to separate the data into two parts. Simply this is called as adding the similarity features. Okay, now we see this one now. Okay, now we are ready to compute the new features. So here we are going to see the x1 equal to 1. This is located at the distance of 1 from the landmark 2, from the second landmark. Okay, from the second landmark. Therefore, the new features are based on the Gaussian RBF function phi of gamma into gamma of x comma l equal to exponential of minus gamma into x minus l whole square. That gives the, so now we are going to find out the new value equal to exponential of minus 3 minus 0. That is gamma value, and here the x equal to the corresponding x equal to 1 minus 1, and the new value the corresponding landmark equal to minus 2 minus of minus 1 equal to 1 square. Okay, whole square. Okay, if we substitute these values in this equation, we will get the 1 square, that is equivalent to 0.74. That means here the we are going to compare the landmark of x2 and x3 with respect to minus 1, that is equal to 0.74, and for the first landmark, and the second landmark we are getting the value as 0.3. Okay, so if we substitute these values, okay, we are getting the second wave feature is exponential of minus 0.3 into 2 square, that is equivalent to 0.30. Like that, we are getting for the each and every original data set, we are finding the corresponding new features with help of Gaussian radial basis function. Okay, so they are the new features, that is x2, and this is the x3 with the help of the support of new landmarks, landmark 1 and landmark 2. Landmark 1 equal here minus 2, landmark 2 equal to here 1, and these are the original x value. So now with this finding, we are finding the new features, that is x2 and x3. Now with the help of this, we are going to spread the graph between the x2 and x3. Now now we are getting the distribution look like here. Okay, so all the blue points are very close to each other, and all the green color points are very close to each other. So these points are easily we can separate with the help of some line equation. Okay, now so this is the way we are going to classify the data into two parts. That means first of all we are converting the non-linear data into we are transforming into other format of other features, and based on the new features we are going to spread the data into two parts. Okay, that data is going to be classified with the help of a linear equation. Okay, now we are going to classify these green color points and blue color points with the help of linearly equation. That is a linearly separable. Okay. Now you may wonder how to set the landmarks. So the simple approach is to create a landmark at the location of each and every instance in the data set. Doing that, creates many in dimensions and thus increases the chances that the transformed training set will be linearly separable. And the downside is the a training set with m instances and n features get transformed into training set with m instances and m features. Okay. Now, if your training set is very large, then you can end up with a equally large number of features. Like that, we are going to convert the non-linear features into linear features. Okay, then we can separate it to linear equation. So simply this is called as a adding similarity features. Okay, with the help of Gaussian radial basis function. In the next video, we are going to discuss about the Gaussian radial basis function kernel. Okay, thank you. Thank you for watching our video. If you like the video, please subscribe my channel. Thank you very much.